Water scarcity is one of the most important issues in the world. Around 1.2 billion people, or almost one-fifth of the world's population, live in areas of physical scarcity, and 500 million people are approaching this situation. Statistics shows that water use is increasing much faster than population. Globally, we use 70% of our water sources for agriculture and irrigation, and only 10% on domestic uses. Greenhouse uses approximately 22,000 gallons of water per day for irrigation purposes. In a greenhouse, 2 fans pulls in the hot air through the wet pads. Air temperature decreases while it passes through it. Air saturated with water is then exhausted outside the greenhouse. To avoid this, a heat exchanger system will be provided in order to condensate most of the water wasted in the exhausted air. Water sump can be used to collect excess water under the wet pads. The water under the wet pads is already cooled but also needs to be cooled further by a small refrigerator. Then the lost water will be pumped to the heat exchanger system to condense the steam and turn it to water. After the condensation process, the emitted water will be taken back to the water tank and the water steam will be transformed to liquid, which will also go back to the water source to be used for wetting the pads. We used computational fluid dynamics to design the greenhouse water recovery system. When the fans are opened, air mixed with vapor starts spreading over the room. The red color range shows high humidity level. After a few seconds, the greenhouse will have stable high level of humidity through the whole room, which will exit to the condenser. This high humidity proves that we can capture more than 50% of wasted water before exhaust. Therefore, by constructing this modern and innovative greenhouse, we will extend the productivity and the quality of off-season crops at a low cost, as well as we are able to save significantly more than 50% of the wasted water.